My name is Josh Jansen. I'm a director of data science. And today I want to go through a app I've been working on that really compares this new GPT model of O1, which is designed to really excel at more complex reasoning tasks against Google's OR Tools optimization library. And I want to compare the two to kind of understand the limits of one or the other and how they both perform. So let's get into it. Here's the application, and I'll get into the code in a few minutes, but first of all, I want to show you how this could work. Okay, so this sample application is, think of it as a roster or team rotation manager for a basketball team. It really could be any sport. But what you get is you have a number of players, and with basketball, you can only have 5 players on the court at one time. And there's other constraints that I have set up with this particular problem. And if you know anything about optimization, you know it's all about constraints and finding the optimal solution. So we have a game length of 40 minutes, 2 20-minute halves, and required every 5 minutes substitutions. And we want to spread the playing time out evenly of all of the players. And a maximum of only 2 beginners can be on the court at one time, and there must be at least 1 point guard on the court, and also no players should have to sit down over 2 5-minute periods. Now I've set this up to run OR Tools and GPT-4o. First of all, I want to demonstrate OR Tools because that's very fast. And one of the limitations I noticed right away is GPT-4o, not a surprise here, is going to take some time, and it's somewhere between 2 to 3 minutes. So I'll go ahead and do OR Tools, then I'll come back to the results for GPT-4o. So I'm going to load in an additional roster. I've got players 1 through 8 listed here. I'm going to go ahead and just fill in some values and just randomly select some players to start. And when I go ahead and click optimize the rotation, I'm going to get a result that looks like this. For every 5 minutes, it tells me which players are going to be on the court and which ones are going to be out on rotations. And then down below, it's going to summarize the distribution of playing time for each player. Player 2 comes in at 40 minutes of playing time, and the rest of them are at either 20 or 25. Player 2 gets much more because they're the only point guard, and that's a constraint, is we need to have 1 point guard on the court at all times. So that's OR Tools. Very nice, very fast. That was split second. Okay, I'm going to go ahead and reset this. And then I'm going to leave the same roster, and I'm going to jump down to GPT-4o. And I'm going to go ahead and click Get My Optimal. And we're going to look at the differences between the two here in a second. While that's running, like I said, it takes a little bit of time. I'm going to go ahead and I'm going to show you the repo. And if you ever want to install this, I'll include this in the show notes down below, this repo, and you can build this in Docker and get the exact same output that I've got here. And this talks about OpenAI's O1 model versus OR Tools, some of the constraints, and how to install all the details you need along with the product structure and all the code associated with it. Going into the code, let's take a look at this. There's really 2 key files. The first one is going to be what lives in my backend API service, which is FastAPI. And here, it's going to be calling the GPT model. Go jump down to that here, and it's going to rotate through. Here's my constraints, and it's using a prompt, basically setting up the constraints. So what I will do in OR Tools, using OR Tools library, I'm here just taking advantage of a prompt sending to that OpenAI O1 model. Now you'll notice I have O1 preview in here because it's in preview for a developer like me. There's also a mini O1 mini model, which I ran it on this data set, and it actually came back quite a bit faster, under a minute versus about 3 minutes but it didn't really provide back as quality as optimization as I would want, which really isn't a surprise. So basically, I go through here and I'm going to return the optimization or the large language model response. And then from there, that's going to bring it back to my Streamlit application. And I won't go through all of this code as you can look at it yourself. But here is the code for the front end of the application that I shared with you that goes through all of the either or tools, which I actually have just living in the browser because it's a very lightweight library. So I didn't have to have that sit within the backend of FastAPI. And so either or, you can see the options in here and how this is going to work. All right, so going back to, let's get, and this is still running. So it's been about 2 minutes where it's actually communicating with the large language model from OpenAI. Oh, and we've got results back. So using the exact same thing, you can see the results are actually pretty good. And they're actually, I believe, exactly the same as OR tools, where player 2, which again was that point guard, which is a constraint that I've set up, they're going to get 40 minutes. That's the entire game. They're required to be on the floor. And then you can see I've got the other group of players will have 25 minutes and then 20 minutes for 3 players, which is really nice. So this, and I have a validation check both for OR tools and for the O1 model that a point guard is always present, that they're valid, and then no consecutive sitting and balanced play time across all players, because that is a goal of this optimization program. So that's it. I think the takeaway here is that for very lightweight optimization activities, if you don't have to or don't have the expertise in using optimization software, and maybe just for POC purposes, using a O1 model gets you pretty good results. Now, if this was a very large data set, I would definitely not go down that path of using O1 model, but it does handle fairly a number of constraints and quite a bit of process using agents in the background to solve this, which is very promising. So there's my comparison. I hope you enjoyed it, and leave any questions in the comments below. Enjoy it. Thanks. Bye.